Good morning and welcome to today's webinar around reconnecting for smart and sustainable mobility and leading us towards the ITS European Congress in Toulouse end of May. My name is Lisa Bock-Andersen. I run communications and congresses for Ertico ITS Europe, and I am delighted to be your host today. So just to introduce this webinar for those who are joining for the first time, this is the second in a series connecting the dots and getting us on the way towards the actual Congress. And each of the webinar will be focusing on one of the key topics of the Toulouse European Congress. And today, the topic is next generation solutions and mobilizing for the future. And that is, of course, a very broad topic with lots of expectations in terms of mobility being sustainable, connected, electric, autonomous, and there are so many topics that fall within this, including digital enablers like 5G, 6G, including 3D mobility, including, of course, also data and information as key enablers. And we have gathered a number of great experts today that will talk about all these items. A quick overview of the agenda, which falls in two parts. The first part is a little bit more focused on the Congress. I will give a quick update, followed by a welcome by Joost van Tomme, our CEO at Ertico ITS Europe. And then we will have Parifex, one of the exhibitors that you can meet in Toulouse, with Nathalie Deguin, who will talk about 3D LiDAR technology for safer roads. And after that, we move into the second part, which will be a panel and which will go more in depth into the topic of today. And the panel will be led by my colleague Koen Bressard, who is Senior Manager of Innovation and Deployment at Ertico. And Koen will introduce the panelists when we get to part two. I just want to mention that we also have a second exhibitor, Monoj, who you will be able to meet in Toulouse as well. I think we have a quick slide on a couple of rules, house rules. Indeed, everybody is in listen mode only, and we will be recording the webinar and share it through our channels. Also, we hope there is time at the end of part two to have a Q&A. And there is the Q&A opportunity in the GoToMeeting up right corner. And you are very welcome to write your questions along the way. So with that, let me give you a quick update of the Congress. This slide is just a reminder that we're talking about a 3-day Congress from Monday to Wednesday, so we look forward to welcoming you on Sunday. It has a high-level program with opening and closing and plenaries, but it also has a very important technical program with specialist sessions running through every day of the 3 days. Perhaps one update on the high-level program. We have a fantastic inspirational speaker who is landed, Dr. Sylvestre Maurice, who is an astrophysicist from Toulouse. And you can see here to the right in red, who's made many exciting discoveries. So we look very much forward to having him help us open the Congress. Perhaps also a word on another key feature which is very important. It is the ITS Summit that we have had for a number of years in our congresses. And it is quite a unique opportunity for industry leaders to meet representatives from the senior government, be it at local or national level. And it is really an opportunity for these two parts to discuss in roundtables, and it is a summit which normally is very much appreciated because it actually doesn't happen that often that you sit down and discuss rather than go and have a presentation and leave. So this year we're focusing on different aspects of mobility data. You can see them listed here. Everything from ownership of data, the willingness to share the data, access to data, but also very importantly, the whole discussion around inclusion and digital divide, and last but not least, interoperability. It's important that, you know, the whole thing talks to each other, and of course also the data sharing between the public sector and the private sector. So lots of interesting topics to be discussed there. Going forward, a quick word on exhibitors, I believe, if we can see the next slide. I don't know whether the slides are, there we are, the technical program, thank you. Very importantly, I want to thank everybody because we got over 300 submissions for our technical program, for the special interest sessions, for the technical papers, the research papers. So that is just absolutely fantastic. Thank you very much for all your contributions. And as a reminder, the contributions, they will, of course, create a whole range of technical sessions that will cover each of the 5 key topics of the Toulouse Congress that you see listed here. Next slide, please. Exhibitors, indeed. So as you know, the Congress features not only a high-level program and a technical program, it also has a very comprehensive exhibition. And I invite those of you who still haven't contacted us to go on the Toulouse website. Here you see a number of logos of organizations and companies who have already signed up. So as I say, I vividly invite you to join them. And also just want to highlight that there is also opportunity for commercial partnership, whether it is sponsoring a seat in one of the high-level plenary sessions that I was talking about before, whether it is promoting your organization through a workshop or through one of the app features. It's all about thought leadership and brand exposure. So again, I invite you there. There's also the link for the commercial partnership brochure. Have a look on the website and see if there's something that would match your needs. I think one very important slide is left here on registrations. I am super excited alongside Ertico and the broader team to announce that registrations are now open. If I were you, I would sign up before the 19th of April because then you can benefit from the early bird promotion. And last but not least, we have, I think, a reminder of how to keep up to speed, how to keep up to date with everything that's happening up to the Congress. You have here the website, but also our channels, Twitter and LinkedIn, or you can go on the website and sign up to the Ertico newsletter that comes your way every 2 weeks. So with that, I would like to hand over to Joost, our CEO at Ertico, to have a welcome. Thank you, Joost.
Okay, thank you very much. I hope you can hear me. Technology works, so that's fine. Welcome to all of you, and Lisa, perfect introduction with the team. I'm honored and very grateful to all the work that has been happening. We've been intensively working with the Toulouse team. I see some of them are online here. So thanks to Evelyn and the whole team there, and welcome to this second webinar. It's quite a ride and journey that we all have to go through. in this pandemic still. We hope to lift a bit of the constrict, I would say, the restrictions, and we have good faith that everything will be floating and going fine. And this webinar is a second one and is focusing on the next generation solutions. That's mobility tomorrow as we see it from our point of view at Ertico with our members. This you see, it's definitely ITS. I did some interviews recently and I asked the candidates, please explain me what is ITS and can you give me an elevator pitch on this one? Well, my friends, I can tell you I've heard all kinds of stories, but everything has to do with technology, with connecting all these dots that you see, and with smart mobility. So at least all these candidates had the right tagline. It's about smart mobility and sustainable mobility. So all this will be discussed, and we believe that in the digital and data strategy of the Commission, which we very much favor, we believe that all these things have their benefits for the economy in general and society, not only safety features, for connected vehicle safety, for example, public transport as well, but also efficiency, throughput of traffic, better use of space and land, and more on-demand mobility as well. All this is captured through EU-funded projects. We have a lot of them here in Ertico. We recently won a couple of new projects, and very happy also to lead this with the team. On data, I think Christophe will also mention that from DG Connect, but clear that we go to an edge computing approach, which is totally different than the cloud computing that we have today. If we see these figures coming from Commissioner Breton and Mr. Viola and the whole team, I was impressed by these figures. I checked them, and indeed, when talking to automotive and many other sectors, it's true, everything will be at the edge, or at least a lot of things will be at the edge. So partnering of Ertico in all these spaces of mobility, these are just a number of projects. I think we have 15 of them dealing with data sharing and advocacy and actually technology, make it happen amongst all these dots that we connect, and happy to see them live in the Congress in Toulouse end of May. Next slide. So this session is about new opportunities, new mobility. Koen and the team of Ertico will guide you through with some of our expert outside colleagues. It's definitely connecting the dots. It's about the Internet of Mobility and mobility management. The new normal, I would say, multimodality. Obviously, we've seen all the strategy of the SSMS, so the Sustainable Smart Mobility Strategy of DG Move, Mrs. Valian, together with the digital and data strategy, and now also the 10T, the urban mobility approach. So all this comes nicely together in everything we will showcase for you at the Toulouse Congress. Mobility spaces, definitely an important topic. I think Christophe will mention that also in his presentation today. Artificial intelligence. So we are holding a deep dive session with our partners on what it is, AI, how does it work, deep learning, but also machine learning, and how can it connect the dots with more intelligent algorithms for it. It can be automated driving, autonomous driving. It can be many other applications, I would say. So our transport sector is service-based and would like to have the users as a central focus, the professional users and the consumers. So very happy to have all of you in this call, very numerously. And back to you, Lisa, for the rest of this day. Thank you.
Thank you very much, Joost, for that nice welcome. And now, as I said, Nathalie from Parifex is one of our exhibitors that we look very much forward to welcoming in Toulouse. And for now, Nathalie will give a little appetizer in terms of technology for safer roads. So Nathalie, the floor is yours. Over to you.
Thank you, Lisa, for the introduction, and good morning, everyone. I'm very happy to be here today with you, and I'm really looking forward to this ITS show in Toulouse. I hope to see you all. Today, I will be talking about 3D LiDAR technology and how this technology can actually help road authorities making our roads safer. I will begin with a very quick introduction on Parifex. So Parifex has been providing the French government with speed enforcement system for the past 25 years now. Currently, we have about 400 equipments deployed all over France. We're actually one of the main providers of the French government. There's going to be 500 additional ones to be installed by the end of this year for the supply of multi-violation systems. I will go into more details after. Parifax, it's also 15 million euros of turnover, currently 66 employees, and you'll see in the presentation that we take great importance in innovation as we invest each year between 15 and 20% of our turnover. Next, please. And then I will begin with a very quick focus on mortality rates. As you know, it's a major concern and it's a global health issue. Today, the World Health Organization estimates that 1.3 million people lose their lives each year on the roads. In France, it represents 2,500 people who died in the roads in 2020, 45,000 physical accidents causing 55,000 injured. So obviously 2020 is not very representative because of the COVID situation, but I think we can all agree these figures are always too high. Now, if we look at the users, the most vulnerable ones are the pedestrians, cyclists, and two-wheelers. One accident out of two is fatal. Most victims are men, and actually 20% are between 15 and 24 years old. The road is actually the primary cause of death in this age range. So all this to say that we have, if you can put yes, that we have that we should not only focus on speed limits. We should take into account these figures and we should find ways to protect all these users. So we should not focus on speed limit, but also try to focus on all behavior-related violations. So that's why at Parifax, we actually have a wide range of solutions suitable to different situations and different applications. For instance, we have the Vigie. It's actually the one that is installed all over France. It's more suitable for highways. And in addition to speed measurement, we are also able to do vehicle classification as we make the difference between passenger cars and trucks. As you know, trucks, when they're implicated in an accident, it's usually fatal. Vigie double-side interception is the double-side version. It takes two pictures of the same vehicle from the front and from the back for a better performance, for a higher number of offenses recorded, and also to be able to detect better the motorcycles. The nanocam now is actually my focus today. It's the sensor we've developed using 3D LiDAR technology, and it can actually be used in many applications. I call it our multi-tool sensor, as it can be used as a mobile enforcement device to be used on a tripod, or it can be used integrated in other solutions as a speedometer, or it can be used as traffic data collection tool. And now, why is the 3D LiDAR so useful to be able to cover all these features? So for those of you who are not familiar with this technology, basically it's layers of laser beams that rotate at 360 degrees, retrieving point clouds like the one you can see on the image. And for each point, we have the polar and Cartesian coordinates, allowing a 3D modeling of the environment. And what we did, and all this in real time, and what we did at Parifax is that we developed an algorithm to be able to detect any moving targets in its field of view. And for each target, we collect very precise data information. For instance, for each object, we have the precise position, we have the speed, we have the dimensions from which we detect the category of vehicles, we have the direction, the acceleration rate, the distance, etc. All this with this very unique and compact sensor that covers all these features in real time. So speed measurement, classification, identification, tracking, and all this precise data collection. And what we did for this latest solution, the Nomad, so the said multi-violation system, is that we actually combine different technology. We combine the 3D LiDAR technology and the camera using artificial intelligence and image processing techniques to be able to cover even more violation. Like I mentioned, all behavior-related violation, meaning all that is related to the driver attitude, we are using the camera in addition. So all this combined allows us to monitor all the violations I listed below. So red light enforcement, speed enforcement, stop line crossing, reserved lanes, monitoring, pedestrian priorities, safety distance, seatbelt use, phone use. We can even cover low emission zone control, one-way driving, and we have our own integrated AMPR. The advantages also to have a system like that is that it's completely non-intrusive, doesn't have to be connected to the street lights in any way, you don't need any additional civil works, and the precision is very, very interesting, and the processing treatment as well. So all this to conclude that you've seen the possibilities of the 3D LiDAR. You've seen all the data that we can actually collect in real time. It's very precise. It's actually precise at a centimeter. The processing time is very quick, and we have been using it for our application. Actually, I have to say that in our field, in the speed enforcement field, we are the only one using this technology for speed measurement. But it can also be used for any other applications, like it can be used for traffic management, traffic counting. We have also been working on autonomous vehicle projects. We have had some experimentation also for smart parking. So all this to say that the 3D LiDAR have very wide possibilities, and that it can be very useful to make mobility smarter and safer. That would be the end of my presentation. Thank you very much, and looking forward to see you at in Toulouse.
Thank you very much, Nathalie. That's very interesting. Some worrying figures around vulnerable road users. So it is good to hear that you're really getting the most out of the technology to ensure that we increase safety for all. So I, for one, look forward to your exhibition in Toulouse. With no further ado, I would like to hand over to my colleague Koen, who will moderate the panel going forward. Koen, over to you, please.
Thank you, Lisa. Koen Bresser, I'm one of the senior managers at Ertico. And before we dive into, I would like to shortly go back to the word cloud for the next generation solutions that Lisa has very nicely shown earlier. And I want to dive a little bit deeper into this because this topic has some subtopics. Can you go to the next slide, Cordelia? There's some subtopics. These are them. And if you look at it, it's all about data and information. So the digital twins, simulation and modeling, maps and geolocation, next generation AI, the next generation communications, resilient data infrastructure and data framework. Basically, it's all information or data, whichever you prefer, for the benefit of urban air mobility, autonomous transport, platooning. But in the end, it is all for the mobility of persons and goods. Cordelia, could you skip to? It's all for the benefit of people and goods. So if you go to the next slide, you can have, there are some aspects of information that are relevant here. And there's a relation to the FAIR data principles for the ones who know it. It's a scientific way to share data. So it's findable, accessible, interoperable and reproducible. Basically, it's about the availability of data, how to find it, standards, platforms, APIs, data warehouses. Ertico is very active in that, for example, with Sensores, Adasis, or Arcade. Another aspect is how to get the data. So it's nice that you know where it is, but if you're not able to get it, then you're still in the dark. So that's about communication, seamless and cross-border. And for that, Ertico has some projects and platforms like NAPCOR, 5G Mobix. And the last one is the interoperable topic, how to use the data. That's about persons and systems. The data should be usable for persons and systems. In the end, we will have a period in which SICAM will drive on the street together with manually driven vehicles. So that needs to be done. So then we're talking about semantics. And then we have some projects, platforms like EMI3 or Phoenix. And looking at this, next slide, please. Looking at this, we also have some very interesting speakers for you related to these principles. For example, Menno Malta from Monoch, he will discuss, CEO and the founder, he will discuss how to make traffic talk. So that's about the data exchange, how to get it. We have Christophe Almassi, who will cover for Dr. Max Lemke from DG Connect, who will share with us how to get data. And we have Tom Alkien from NetTM discussing on how to use the data. And I would like to start with Menno, if you are available. Menno?
Yes, of course, Koen.
Before you start, there is a chat box, not a chat box, there's a question box. So if you have any questions, we will have these questions later for the speakers. So feel free to use the chat box, and let's listen to Menno. Go ahead.
Thank you, Koen. So good morning, everyone. Yeah, my name is Menno Malta, and CEO of Monoch. I'm happy to speak here. And I want to share something today about our vision on the next generation solution, specifically for CITS. And I think before we can talk about what is the next generation, we should look at where we are today with CITS. And first, CITS today is a bit like the photograph on the left here on this slide. So very interesting, but still a bit for a small audience. And for us, when we talk about next generation, that's the aspect that we want to change. So we think that the next generation of CITS should be like the picture on the right for a massive audience and with a lot of impact. The good news, we think, is that this is very much within reach. So I'll share a bit today about how we think we can get there. Before I do so, let me briefly introduce Monoch to you. Monoch is a Dutch company with a focus on aggregating and exchanging CITS data, and with a strong focus, again, on large scale and the elements that you need to manage that data exchange. So I will also share during my presentation an example of how we do that. Well, back to the current state of CITS. So what is CITS? What is the world of CITS? And first of all, we think it's important to recognize that CITS is an ecosystem game. You can have one click on the slide. Thank you. So we have this ecosystem where it's not just about the authorities, and it's also not just about the road users, but it's really about this ecosystem with vendors of roadside equipment, with authorities and owners of roads, and we have traffic management centers, analytical and R&D companies, and then of course we have the service providers, CITS applications, and the road users. And all of these different stakeholders need to share data. It's not an ecosystem where the data flows from one side to the other side. It's really an ecosystem where data is created and consumed by all the different stakeholders. The good thing is that there's also a lot of progress in the last years, the last decade maybe I could say, where use cases have been standardized and tested and proven more and more. So you've seen a lot of research, and I think the impact, the potential impact of CITS is very well researched and proven. But there are also a number of obstacles that are still there. So we see technical obstacles, identification, security, data quality, latency, means of communication, and equally important, we also see organizational obstacles, governance, privacy, standardization, and we think these obstacles are blocking this large-scale deployment that we're looking for. So for that, we have developed a platform which is the TLEX platform, the Traffic Live Exchange platform, and this is really a platform that serves the entire ecosystem and which helps overcome these obstacles that I just mentioned. I think to make this more come to life, I would like to describe an example of how we deployed such a platform. So this is the Dutch deployment of our platform, where the TLEX platform is at the core of the national UDAP service, as it's called, the Urban Data Access Platform, which is again part of the national access point of mobility data. And here we have 3 use cases live on a large scale. We have the prioritization of designated traffic, so from emergency vehicles to public transport, even to bike platoons in certain areas. We have a use case live where status data from road users is used to improve the traffic flow at intersections. And we have a use case where traffic is informed about time to green times. And out of the 40 main cities in the Netherlands, 29 of those have now connected equipment to this national platform. And I think even more impressive is that we see that there is approximately 2 million active vehicles connected in this ecosystem out of the 8 million. And these are figures from the National Ministry of Infrastructure and Waterworks, by the way. And this leads to an amount of over 1 billion CITS messages that are exchanged every day in the ecosystem. Well, that's technology. Then we look at benefits, again, out of research studies conducted on behalf of the Ministry of Infrastructure in the Netherlands. And we see benefits on CO2 emissions, reduction of travel times for road users with priority, and also safer roads. So without going into the details, because everybody can look at these reports, but I think this is a good example of an impactful CITS deployment and ecosystem. And the interesting thing is that once you have this ecosystem in place, it's fairly easy to add other use cases. And in the Netherlands, the next use case will actually be the sharing of emergency vehicle approaching messages, starting with ambulances towards the end of this quarter, and then building on with fire trucks and other emergency vehicles. And this will also bring other service providers into the system, such as TomTom and InRix. So we expect even more vehicles connected and more impact. Continuing to my almost my final slide, this is really where we think that CITS should go. So we see also very interesting day 2 or even beyond that use cases. We think that the major win is now in changing the skill of CITS. And for that, Arterius platform can be really beneficial. Everybody can use it for tests, proof of concepts, and pilots, and start small and grow to large-scale deployment. And this is really now kind of a menu that authorities and other stakeholders can use and play with, where they can decide to use different types of interfacing, change the interfaces during the project, decide on the type of messages they want to use, as these are all the typical types are all supported in this platform. And also we've developed together with the industry standards to connect roadside equipment. This brings me to my final slide. We're excited to be present at the ITS European Congress in Toulouse, where we also have a booth. And we have sent in a number of papers, so hopefully these papers will be accepted, and you can also find this in the Congress program. And then you can learn more about the subject that I was talking about. We're also present at Intertraffic, so you can also find us there. And of course, have a look at our website and our social media accounts. Thank you.
Thank you, Menno, for the comprehensive overview of what you're doing. Very interesting. And looking forward to talking more about that at the ITS conference. Christophe Almassi is from DG Connect, the policy officer covering for Dr. Max Lemke. And he will discuss the enablers of the digital transformation of mobility. The floor is yours. Go ahead.
Thank you, Koen, and good morning, everyone. I'm happy to represent today DG Connect from the European Commission, covering up for my head of unit, Max Lemke, who is responsible for IoT. In this presentation, I would like to present some key trends transforming mobility and what we see as some essential digital enablers for this transformation. To start with the vision, the Sustainable and Smart Mobility Strategy sets out the vision for EU transport in the coming decades. One major challenge will be to reduce environmental impacts, notably to cut greenhouse gas emissions from transport by 90% by 2050. Digitalization is essential to achieve these ambitious objectives, but it will also help make transport safer, more efficient, more accessible, and more resilient. And we see that some major trends are transforming mobility. We have the rise of electric and decarbonized vehicles. Increasingly, mobility is connected and also automated with the strong developments in autonomous driving. There's also a new generation of mobility services centered on the user, often based on mobility data, and notably to allow seamless multimodal mobility of both passengers and goods. And all these trends are enabled by digital technologies, which I will present now in this presentation. The first essential enabler is mobility data sharing. For example, it can help combine data from different transport modes to optimize the use of vehicles and infrastructure. Or with mobility data, you can offer new mobility services like smart parking or smart charging, for example. And sharing and pooling mobility data is also essential to accelerate the development of autonomous driving technologies. To train the AI algorithms, you need large pools of data. And so it's important to share mobility data to achieve that. And under the European strategy for data, the EU will support the deployment of a common European mobility data space, which will help build a framework to share, access, and pool mobility data in a secure and controlled way by building a common framework with both the soft infrastructure and the governance framework for data sharing, and as well to support the ecosystem making use of that framework. As Menno was saying in his previous presentation, the ecosystem is essential. So how to achieve that concretely? First, there will be a horizontal cross-sectoral legal framework to promote data access and sharing and ensure trust and fairness in the data economy. We will have, and we already have sectoral legislation organizing and regulating data access in the transport sector, like the Intelligent Transport Systems Framework. And there will be also support under different EU programs, notably the Digital Europe program and the Connecting Europe Facility program. We see that there are already a large number of initiatives, and some were mentioned by the presentations by Ertico earlier, that are helping to share mobility data. For example, at the EU level, there's the Digital Transports and Logistics Forum in the freight and logistics sector, or in Germany, great progress with the mobility data space. And so the idea of the Common European Mobility Data Space is to build on these existing initiatives and promote their interoperability and foster the convergence between them. Another essential element will be the cross-sectoral interoperability, for example, with the energy data space or smart cities data space, so we can also seize these cross-sectoral opportunities. Another essential digital transformation on the next slide that will strongly impact mobility is the paradigm shift towards edge computing. We see an explosion of the data produced with a multiplication of IoT, for example, in smart road infrastructure, as you presented in Natalie's presentation, but also in cars and vehicles. So an explosion of IoT, and currently most of the data is processed on the cloud, but with this growth of data and also with the low latency requirements of applications like automated driving, this won't be sustainable in the future. So we expect that a growing share of the data will be processed closer to where it is produced, so at the edge. Cloud will continue to play a role, of course, for example, for infotainment, navigation, but increasingly we will see the importance of decentralized artificial intelligence and swarm computing, for example, with autonomous vehicles. And the EU is also supporting this trend, notably with the Horizon Europe program and under the Digital Europe program by supporting testing and experimentation facilities for artificial intelligence. Another key digital enabler on the next slide is chips, semiconductors. As with this multiplication of sensors, but also with the need for high performance chips in vehicles to power these new AI applications, electronics will represent an increasing share of the cost of cars and will be essential to basically enable these new applications that I mentioned earlier. Currently, the EU is very dependent on imports and has a small market share on the global stage, which can impact our industries. For example, as illustrated by the recent semiconductor shortage and its effects on the automotive sector. So under the EU Chips Act, we will build capacity and innovation in cutting-edge chips and the related applications like connected cars. And we will try also to increase the resilience of EU value chains by anticipating disruptions and increasing our production capacity. And finally, we'll bring together chips producers and users to design this new generation of processors that will enable these innovative applications for automotive, for example. Finally, one essential digital technology for this transformation of mobility is next generation connectivity, notably 5G. It's what allows creating this computing continuum from IoT, edge, and cloud, as presented earlier. It's essential for connected and automated mobility. And one key challenge is ensuring the continuity of services based on 5G across borders. And that's why at the EU level, we're supporting 5G cross-border corridors for connected and automated mobility, supporting large-scale testing and deployment, and complementing private and public funding. So to conclude, all these transformations, these digital transformations require major investments. At the EU level, we're helping to build partnerships and funding key strategic projects, but this requires large efforts and cooperation among players in the mobility sector so that we can achieve our ambitious common goals. Thank you.
Thanks, Christophe, for this nice overview. And it's always nice to see my key project 5G Mobix coming up in slides. It's very nice overview of the topics. Next one, Tom Alkim, a strategic advisor at MapTM for connected and automated mobility, and you may know him from his former position in DEC. Tom, the floor is yours.
Thank you very much, Koen. It's a pleasure to be here. I currently work at Map Traffic Management. It's a firm that is based in Utrecht, my hometown in the Netherlands. We are currently leading a consortium of a CEDR-funded project. So CEDR is the Conference of European Road Directors. And members of this consortium, you can see them here on the slide. Traficom from Finland, Transport Mobility in Leuven, Belgium, University of Warwick. We have international experts, Kawashima-san from the Keio University in Tokyo, and Steve Schladover from University of Berkeley. We can go to the next slide. First, I zoom out a little bit when we talk about connected, cooperative, and automated mobility. Why do we do this? We do it because it has the potential to make transport safer, greener, and more accessible. But only if it's done right. And how to do it right leads to a lot of discussion. And there are certainly several issues that need to be addressed before we can make it work and do it right. So if you go to the next slide, we can see a couple of areas where a number of challenges have to be addressed. The key technologies are still being developed. They need to be safe, tested, and validated. The legal framework has to be there. Connected and automated vehicles and services will have to be integrated into the current transport system because we are not starting from scratch. And final, but certainly not least, acceptance and trust of CCAM, because if users are not trusting it or are not willing it to use, then there will be no benefits. In this short presentation, the topic is related to the third bullet point of integrating CAVs in the broader transport system, because currently in the transport system, we already have traffic management. If you go to the next slide, the questions that we would have for the future is, to what extent will traffic management actually be different if we have connected and automated vehicles? Currently, we do it for humans that operate vehicles, so we send information to them, either traditionally on the roadside, and that can be static or dynamic, or as you could see in the presentation from Manoj with CITS, you can bring this information in vehicle, but it's still a human that will act or decides not to act on this information, given the context he or she sees. So sending information to humans driving vehicles is different than sending information to algorithms that drive vehicles. Although you could send the same information, but then how is that information being interpreted? Humans have a pretty good level of context awareness, and they can deal with information that is not very explicit. So if you tell a human to be careful because there is something dangerous ahead on the road, we know what to do. But this information is not concrete enough for algorithms. And then mixed traffic conditions will pose added complexity, because then you have to address both types of drivers. So we think that defining the appropriate driving behavior and the response of connected and automated vehicles is a very important task, and we're pretty sure that industry is working on this, but it might be beneficial to have a discussion with other entities as well. And all these elements are related to the operational design domain and all the elements that comprise that. So if you go to the next slide, you can see the operational design domain. It is the set of conditions under which a specific driving automation system or feature is designed to function. And this is more than just a geographical location. There are many elements and conditions that play a role here, and they can either be under your influence or not. It can be external. To visualize this, if you go to the next slide, a couple of years ago, I tried to make a visual representation of the operational design domain framework, which you can see here. And basically, it is the blue rectangle. So in the 2D representation, it shows you the route and the conditions under which it is designed to drive. But unfortunately, this is a theory. In practice, if you go to the next slide, you will see that a lot of gaps will emerge in the operational design domain, and they are usually related to changes in infrastructure, in traffic, and due to weather conditions. I think it is a joint task of all of us to try and overcome those gaps, or if that's not possible, to inform about those gaps and have sensible transitions of control. Now, if we go to the next slide, the work of the CEDAR project, Traffic Management for Connected and Automated Driving, is working on a concept that is called distributed ODD awareness, which means that the vehicle should be able of its surroundings, all the elements that build up the operational design domain, but also the idea that certain attributes or information of those attributes can be provided by other parties as well. So there can also be off-board sensing that can help you with your ODD awareness. And so the distributed element is related to the various sources that can be there. So this is not only a technical challenge, but it's also organizational in the sense where you have to agree with certain parties what information you would like to use for redundancy purposes or to make things complementary. If we go to the next slide, you see here how all these elements come together. So basically, if you have an ODD on the one side and you have the rules of the road that are related to that, and on the other side you have an automated vehicle with certain technical capabilities, if you confront those elements, then there will be a certain driving behavior or not, if it is deemed to be outside of the operational design domain. But I think what the key takeaway is here is that one, deciding whether a vehicle is inside or outside the operational design domain is probably a decision taken by the vehicle itself. The other takeaway is that as road operators or other parties, you can provide complementary information that can help improve your quality or extend the operational design domain. but it does not guarantee that automated driving is possible, because it is always a result of a combination of those factors. So if you have very clean roads with a lot of good information, it's depending on the capabilities of the vehicles to act on that. And I see Koen emerging, so we go immediately to the last slide, where we try to summarize a lot of the challenges that we are dealing with. So here you see a lot of standards and concepts. So the automation levels, the cooperation classes, the concept of distributed ODD awareness, and the infra support levels, the ISAT levels. They all lead to, let's say, automation drivability and how it should be defined in the future. And of course, if you want to know more about this, you would have to come to Toulouse, where we hopefully have a special interest session on this topic. Back to you, Koen.
Thanks, Tom, for this very interesting overview. It's a topic I love to discuss again and again and again, because in the end, we need to get there at some point. So I would like to invite all the speakers to start their camera. Natalie, including you, and Joost as well, because everyone can get some questions. We have some questions for everyone. Not for everyone. We have some questions. I'd like to start off with Menno and Christophe. One of you. It's actually fitting for both of you, but I think Menno, it's better to start with you first. It's about if I drive from A to B, and A is in one country and B in another, I need to cross a border. I may have one communication chipset in my car and the ITS equipment another. In the Netherlands, you have TLEX. But what about outside the Netherlands? How can you ensure that this is serviced? And the same question could also fit for Christophe. But Menno, will you start off?
It's a big question, so I try to answer it in a short way. I think C roads and the standardization that's ongoing there is the best answer to that question. So a network of interchanges that make data available between different countries, but also take care of redirection. We'll fix that, and it's something we have. We will test in the Nordic Way project, Nordic Way 3 project that's currently ongoing.
Yeah, and TLEX is available in that as well, so it's not only the Netherlands.
Yeah, TLEX also supports the C-Road interfaces. So, and we also have an interchange component in as part of the TLEX suite, so we can completely cover those specifications.
Yeah. Okay, Christophe, the mobility data sharing. What's your view as a DG Connect?
Yes, I think this challenge of cross-border interoperability is applying to many different areas among the ones that I presented, and that's also why we, for example, on the mobility data space, we think it's important to work also at the European level, because the data-enabled solutions that are now emerging thanks to national data spaces, in order to scale up, they need to work also in other member states. And also you have a lot of cross-border mobility in the logistics sector, for example. So we believe really trying to build this interoperability at the European level is very important. And also on 5G, I mentioned there are these projects on cross-border corridors. So that's also one action that is trying to support this cross-border continuity. Yeah, but it's definitely an important.
Thanks. Natalie, there's a question for you. You discussed the real-time aspects of your solutions, but what do you mean with real-time? How fast can you detect? Can you use the detection for real-time traffic management, for example? Can you explain a little bit?
Yeah, sure. Well, what I mean by real time is really that the data is retrieved instantly. I mean, for instance, the rotation of the LiDAR, it makes 10 rotations per second. So the data are processed in less than 50 milliseconds, as an example. And it's the same for our algorithm. I mean, there's no post-treatment. The objects are detected instantly. Actually, the system is already in application in France. That's the system we use for the vehicle identification. And then I can assure you that the vehicle is detected instantly. It's the same process for the pedestrian priority, the functionalities that we developed for our latest system. And yeah, it's real time is instant, I would say.
Okay, and that's very useful for operational traffic management and indeed as well. Okay, thanks. Tom, question for you. Actually, I can relate a little bit to that question because I think I'm the greatest driver in the world, as probably you think as well. You mentioned appropriate driving behavior. Who is in charge of determining what appropriate driving behavior is?
That's a very good question, and I think there are several stakeholders in charge of that, or have influence, or let's say a willingness to say something on that. You could argue that the current legal framework is good enough. So if you develop a system that operates within the current legal framework, you're fine. That means that there is a range of certain types of behavior. There is no rule against defensive driving, for instance. So you don't have to do the speed limit. You can drive slower. Even though not everybody will find this appropriate in a certain situation. But we have to keep in mind that the rules of the road were written with humans operating vehicles in mind. And so we may need to have a conversation on what an appropriate translation is of those rules of the road. Because sometimes there are some situations where it is where we allow humans to do something that is maybe explicitly forbidden. You're driving on the wrong side of the road to avoid an accident, for instance. In that situation, you will be forgiven if you do this. But it's very difficult to program all these possible situations beforehand. So you may have different driving styles, behaviors, patterns that you have to think about beforehand. And maybe one practical example that we ran into a couple of years ago when we organized a European truck platooning challenge is the simple question about programming the maximum speed limit, or the speed limit of the trucks, where some of us would say, well, we allow those trucks to drive 89 kilometers per hour because that is about the speed that most of the trucks drive in real traffic, even though it is 9 kilometers above the speed limit. But of course, the voice of reason would say, no, you cannot program a vehicle to break the law. But that means that for mixed traffic operations, you would need to have a discussion to what extent you allow, let's say, these type of behaviors of different types of vehicles to diversify from each other. So I think in practice you will see a lot of situations coming up where I think it's not only the regulators and the developers that need to have a say in that.
And it may even be different per car brand, probably. So your Ferrari drives faster. Lisa, I believe you have a question as well for. You're muted. I still can't hear you, Lisa. You let us practice.
Yes. And I forget to put it on myself. That's not good. A question for you, please. You talked in your introduction about the ethical vision on next generation mobility solutions. The question here is, what role do you see for the European institutions in enabling that vision?
How many hours do we have? No, I think it's the vision is clear. It's about CCAM, that's one of them. Second, about clean and eco-mobility, so the climate and environmental goals. 3 is I would say the whole turn that we have on urban mobility, and 4 is transport and logistics. So these are the 4 focus areas. When I see the regulatory policy agenda of the Commission and then Parliament and Council, they very much are intertwined with all this. And I see a lot of, I would say, reason that the Commission should act even more on this to avoid the fragmentation. Give you one example on CCAM. I still see automated. In my previous job, I was in charge of connected and automated mobility and for the vehicle manufacturers, and I see a lot of national approval systems for automated driving. For example, Germany, France, they have a new regulatory framework for higher level of vehicles approved, but that's a national type approval. So when you cross the border with your nice automated car, well, it will not work in the other country. What will not work neither is traffic legislation. We have 27 different traffic legislation codes, traffic codes, and when you have safety features in a car, some traffic legislation, even if you're driving in fully automated modus, because the car allows you, traffic law will not allow you to do that, because you need to be attentive to the traffic, you need to be in constant monitoring of the environment, etc. So there is some work there. The same with what DG Connect is doing on the mobility data space. We really believe in that. We also went yesterday with quite some consortium on this one through Ertico and some others. And we believe that European data space is the way to go with various interoperabilities across sectors. There's a lot of work to do. And it's good that we take stock of the scanning of the environment with the scan modus proposal. On transport and logistics, a lot of things are part of the Commissioner Valiant's agenda, the TEN-T network, also urban rail, definitely urban mobility. But in terms of transport and logistics, we believe that TEN-T should indeed be ramping up, being deployed much further with CEF and other Digital Europe money. Yeah, so it all nicely comes together, but we need a bit more speed on all this and traction, and that's what we're gonna do with our projects. Voila, Lisa, back to you.
Thank you. Well, so we're on track, but a bit more speed, I guess, is the takeaway message here. Koen, back to you, please.
Yeah, that may be a nice follow-up question for Christoph then from the EC, because speeding up is, if that's the question, and not on the road, but developments, of course. You mentioned chips and to be able to create a better chip industry in the EU. If you extend it a little bit with battery packs and e-vehicles towards sustainability, what are the goals, or what are the things that the EC is foreseeing to get this up and running?
So sorry, do you mean the question? What are the actions to support the transition more broadly?
You mentioned indeed you have the goals, so to build capacity, to increase the resilience, and to bring chip producers together with the market. What are the concrete steps that you foresee?
Yes, so basically there was a recently proposed CHIPS Act. Of course, now it will be negotiated by the co-legislators. I mean, there's a series of measures. There's a more investment at the European level on innovation and capacity building for high-performance chips. In the proposal, there's also measures to better monitor and anticipate disruptions in the value chain. One important action will be also to establish a sort of more flexibility for member states to support first of their kind production capacities on European territory, to also increase our production capacity. And one important also element is the CHIPS undertaking, which is proposed to basically succeed to the key digital technologies and a joint undertaking, which brings together public and private stakeholders to invest in this transformation. So I mean, I invite those that are interested to see also all the material that is available online, but these are some elements from this proposal. Yeah.
Okay, thanks. Lisa.
Yeah, Natalie, another question for you and the ultra efficient control system that you were sharing with us before. The question is around the fact that you use both the camera and 3D LiDAR, and the question is why? What does it bring, this combination? As one would have thought that the camera itself alone would go quite, you know, a big part of the road in itself. So why this combination again between 3D LiDAR and the camera?
Very interesting question. Thank you. Well, everything is in the processing time again, and the fact that we use the LiDAR combined with the camera is that the LiDAR actually pre-select the images we want to treat. So we only treat the images that are interesting to us. In comparison, the camera would have to treat the complete flow of images, which is very heavy and takes more time to process. That's the main thing. It's the same idea with our AMPS software, where we actually detect and pre-select a precise section in the images, and we treat only the section that we've selected. So again, the treatment is less heavy.
Okay. All right. Thank you, Natalie. Back to you, Koen.
Thanks, Lisa. It's nice to see these deep diving, detailed questions together with some high-level overviews. One of the high-level overviews is sustainability. A lot of talks are going around about this, and we need to work towards sustainable mobility. Menno, there's a question for you, because you should have a view in the Netherlands on how what the effects of V2X are on sustainability, and can you elaborate a little bit on that?
Yes. So of course they depend on the use case. The use case really depends the impact, of course. Some use cases have more focus on sustainability, and some have more focus on other parts, such as traffic flow. In the end, we facilitate these use cases. We don't do the impact studies ourselves. These are usually done by independent research organizations. Yeah, that's kind of my answer. What I would say is that by having this ecosystem in place, you can actually start to realize these benefits. We see they are real. And again, but for instance, if you look at the priority use case, one case that we mentioned, there you see very good benefits if you prioritize what is called transport services at intersections, so that you reduce the number of stops, for instance. That definitely has a positive impact on sustainability. And for other use cases, it's a bit harder to really quantify it. For instance, we see in the city of Utrecht, in the center, we see that priority is given to bike platoons. Well, how do you calculate on detailed level the societal benefit there, or sustainability benefit? There definitely is one, because green mobility is prioritized over more polluting transport. But it's a combination of lots of measures that in the end lead to a sizable benefit on sustainability. Okay, thanks. It's yeah, difficult answer, of course, for quite a difficult question. Well, the question is easy, but the answer is more difficult. Again, for you. Well, let me add one thing then, Koen. Sorry, one thing I would want to add. So what we definitely see, that there are strong sustainability benefits for CITS as a whole. So let me add that. Okay, thanks. Your platform, Menno, is sharing data and so forth, all kinds of APIs, all kinds of communication protocols. But within this arena, there is one elephant in the room that everybody knows, that is short range versus cellular. What's your view on that? So for us, we try to focus on the impact and not on the technology. So I mean, every technology has its pros and cons, but we should first think about impact. And with our clear ambition to realize impact in the near future. That means that today we focus on cellular communication because simply we cannot reach enough road users with short-range communication today. And we expect that it will take some time before we see, it will take actually a lot of time before we see a significant amount of road users that have short-range communication devices on board. So that's really why our current focus is on cellular communication. We're also investigating hybrid deployments, and though interesting from a technology perspective, they're less interesting from an impact perspective. But we keep our eyes open and try to onboard all the different technologies as they come available, and also including, for instance, edge deployments, which also lead to short-range solutions. So that's how we currently approach it. Really, from the focus on impact, there we analyze, okay, which technologies can bring us to impact at the shortest term, and that's our preferred choice currently.
Okay, thanks. When taking into account these different communication methods, short range, long range, how do you use which technology, whatever you want to use, they all have their merits. That may imply that automated vehicles and not necessarily have the same operational design domain. Tom, could you elaborate a bit on that?
Yes, the operational design domain is related also to the capabilities of the vehicles. So, for instance, if you choose a certain technology for your precise geolocation, you may have different requirements, and so also a different ODD. So one example from the past is that instead of using GPS, you can also put magnets in the road for precise positioning. These are two different methodologies, but maybe also related to the previous question. I think there's a benefit in multiple sources, so in redundancy and in complementary information, but it's at a cost. So you have to ask yourself, do you bet on one technology, or do you want to take advantage of multiple technologies or sources of information? But it does come at a cost. And I think with ODDs, you can try to extend them also with different sources. So I think communication here is an example of how you can do this by providing and extending the e-horizon. So vehicles can look further ahead, and they can take more strategic decisions and prepare for that. So I think there are definitely benefits there, but they come at a cost, and they come also, and I think this is also a message that I would like to give, a willingness to cooperate. There may be a desire to have everything in your own hands, but there may be a benefit of using information or sources from other stakeholders, but you have to be willing to accept them and cooperate, and that's not always easy.
Yeah, the cooperation is the difficult part. I will say technology you can solve, but the cooperation needs effort. Lisa.
Yeah, I have another question here for you, Joost, and going back up at a higher level again. In terms of cities, what would be the best way forward? Should cities do their own thing, or do we need a more horizontal and streamlined approach across cities for this?
Yeah, thank you for that question, Lisa. Indeed, when we discussed this with the Matthew Baldwins of this world, with Move and the team, is indeed a difficult one. It's a combination and a calibration of the subsidiarity, which means you're better off to regulate it at a local level or regional level versus the European or even beyond Europe level, like UNEC, for example. I believe that, but when it comes to the use of land and the rescoping of the space, because every centimeter has its value even more today, it's better placed that the city is doing that at the local level. However, when it comes to starting to regulate who is allowed to drive where, who is allowed to do what kind of vehicles are allowed on the city, and what's the price of using mobility in the city, there, and I see various initiatives. We see low emission zones, we see city tolls, we see, well, we call them UVARs, urban vehicle access regulations. There's a plethora of variety on that one. A bit of guidelines, a bit of common, I would say, taxonomy would help also for connected and automated driving, because these vehicles will have in their HD maps some information, digital twins of these systems, and I think the RTTI delegated act is pushing to that at least everything is available, but still the variety is very large today. And a bit of guidelines would help, and I think in the urban mobility package there were some guidelines on this one going forward. So it really depends on what kind of thing you want to regulate, if you need to regulate this. Yeah.
All right. Well, thank you. And I see suddenly it is 12:15, so we are out of time. So I want to take the opportunity to thank, first of all our speakers, and Koen for his great moderation of the panel. But thank you, everybody. And also, last but not least, thank you to the participants who have been very active in sending in questions. We hope to have some of you with us again for the upcoming webinar. And of course, we hope to see you in Toulouse. With that, thank you very much for today.
Thank you. Bye-bye, everybody.
Thanks.
Right.
Bye.
Bye. Thank you.
Goodbye.
See you all.